Dear students, once again I am here to guide you today, especially in the differential calculus. Differential calculus, actually, the maximum student, as I have seen during my last 37 years of teaching, they feel very difficult. Because the reason may be that students do not concentrate over the definition, formula, as well as the simple question. Directly they see the chapter and start the solution of the question. That will not do. If you want to become perfect in any topic in mathematics, you must have to concentrate properly for the definition as well as formula. Dear student, more than 70% of your mathematics, that is all depend upon calculus, whether it may be the differential calculus as well as the integral calculus. Today, I am going to discuss first of all, actually the property, formula, which you use throughout the calculus, whether it may be the differential calculus or integral calculus. And that is the basic concept of your differential calculus. I will take the formula, accordingly examples related with that formula, so that you will understand the concept of differential calculus and you will find out the solution easily of the questions. As in the previous videos, I discussed related with the inverse trigonometrical function. Today also I will take some questions related with the inverse trigonometrical function. Because in the inverse trigonometrical function, we reduce or we change the given functions into the simplest form. Then easily you got the differentiation of that function. Today, I am going to take the formula in the beginning of the differential calculus. Concentrate over here, dear student. This is the function in the form of x. fx and gx are the functions. Be the two functions. Functions, and these are derivable, differentiable in the common domain, are differentiable in the common domain. You must have to keep it common domain. Related with the domain and range, I discussed a lot in the inverse trigonometrical function. Let me take first case, dear student. First formula. Without these, I will discuss the four conditions, and without these four conditions, it is very difficult to get the solution or the solution of the questions in differential calculus. Let me take f x plus gx, that is the sum of the function, and we are going to differentiate of sum of the function. Very simple. Already I have given these are the functions in the form of x that will be variable. Function will be given in the form of x. Not only in x, function may be in the form of s, t, u, v, whatever it may be. But here we are taking the function in the form of x. Sum of the function, you find out its derivative, or you can say that derivative of sum of the function will be equal to sum of the derivative. Dear student, that is a very important thing which I have started to discuss with you. If you want to become a perfect in differential calculus, you must have to keep in mind these four conditions related with the four properties related with the differential calculus. Once again you see, some derivative of sum of the function is equal to sum of their derivatives. Okay, let me take the example. Suppose the question may be given on dependable. Find the derivative or you differentiate it. Find the derivative of sin x plus cos x. Where x, that is the variable. With respect to x, you will have to find out its differentiation. As I told you, here we have taken x. In place of x, you can take theta. Then you will find out the differentiation with respect to theta. You understand? That is why you must have to see what is the variable. Okay, try to get its derivative with respect to x, and sum of the function it is given. My dear student, there is a chart. You must have to review that chart of differentiation of different types of algebraic function as well as trigonometrical function, exponential function, logarithmic function. That will be beneficial for you while you are going to start the differential calculus. Okay. Here it is given that derivative you will have to find out of the sum of the function. Then it will be easy. You separate it. Sin x plus derivative of cos x. Dear student, just to remember, I will tell you the very important thing. You know the derivative of sin x with respect to x, that will be cos x. And derivative of cos x will be equal to what? With respect to x? Minus sin x. Minus sin x. Generally, student, they forget what will be the differentiation. Why? What will be the differentiation of sin x and cos x? And cos x also differentiation of cos x, they write sin x. They do not put minus sin x. That is why I am going to tell you one thing which is very important. Just to remember only. Whenever the co comes in trigonometrical ratios, co, whether it may be cos, cosec, cot, whatever it may be, its differentiation will be in the negative form. For your convenience, I have just told you this thing and you must have keep in mind. Okay, then differentiation derivative of sum of the function is equal to this one. I think it is very easy, and you must have to keep in mind, then it will be very easy for you to find out the solution of different types of functions. Let me take second case. In the second case, that is also easy. In the second case, I am not going to write it once again. I am just taking it. Here I am putting 2. Second condition. And because we will take the difference of the two functions, because it will be same. Difference of the two functions. Here also I will put the negative symbol. And I am taking difference of the two functions. Same thing. Differentiation of the derivative of difference of the two functions will be equal to difference of the derivative. Okay. Same thing, differentiation of sin x, that will be cos x. Differentiation of cos x, that will be minus sin x. That is why here it will become positive. Very simple thing. And other two things are important. As I told you, not only here in differential calculus, you will use these 4 conditions, you will use in integral calculus also. I am going to take the very important condition, which is very important, and generally the student commits the mistake in this condition for differentiation. Let me take third case. In the third case, dear student, see, whenever the product of the function will be given, product. Most important thing while you are taking the product of the function, and see, when product of the two functions fx and gx will be given. must have to assume always this is the first function, this is the second function. Just for to make it easy, I have mentioned over here, I have assumed it will be the first function, it will be the second function. Product of the function, here it is given. In integral calculus also, you will have to find out the integration whenever the product of the functions will be given. Here, we will use this procedure. In integral calculus, you will use integration by parts procedure. The first function you keep as it is for fx and derivative of the second function. Very easy formula. Dear student, you must have seen. Second function you write as it is and derivative of the first function. Very simple formula. First function you keep as it is, derivative of the second function plus derivative of the first function you will write, but second function you write as it is. And suppose the question will be there, that we take find the derivative. Find the derivative. Same example I will take derivative of sin x into cos x. This is fx and this is gx. Same thing. In the previous two conditions, I have used sin x and cos x, plus minus symbol it was there in between them. Now here, derivative of both the function. Dear student, as I told you, keep this is the first function, this is the second function. Just to remember. To make the practice, to keep in mind, I have mentioned here, first function, second function. Okay, first function, dear student, you write as it is. And derivative of the second function, that will be derivative of x plus. Second function you keep as it is. And derivative of the first function. Very simple. Simply you can find out its differentiation. But it will play the very vital role to find out the differentiation in different types of functions. As we will discuss a number of questions related with this property, which is very important, and the student generally commits the mistake. Sin x you put as it is, and derivative of cos x, as I told you just before, minus sin x. Okay, cos x you put as it is, and derivative of the second function, that is cos x. Okay, dear student, minus sin square x or plus cos square x. Even though you can, if you want to put it, sin is cos square x minus sin square x. That is a formula of sin cos 2x. It is a formula of cos 2x. You see, cos square x minus sin square x. So many conditions automatically comes while you start the solution of the question. Okay, last formula, which is also very important, I am going to take whenever the functions will be in the cosine form. That is the fourth form. Fourth form, I am going to take when the cosine form of the function will be given, then how will we find out the differentiation of it? Differentiation, cosine form, dear student, you see the cosine form. I told you that it is very important function, that is fx upon sin x, fx upon gx, first of all, let me take. It will be equal to, dear student, whatever it is given in the denominator, you get the square of it. Write it square. Gx is square. Gx, you write the function which is given in the denominator, you write as it is. Derivative of the function which is given in the numerator, minus the function which is given in the numerator, you write as it is, and derivative of the function which is in the numerator. See, once again you see, whatever it is given in the denominator, you must have to write x square. And what is, you write here, the function which is in the denominator, as it is, derivative of the function which is given in the numerator, minus, you write the function which is in the denominator, and derivative of the function which is given in the denominator. Okay, Let me take the example. Similar kind. Find the derivative. Find the derivative. Find the derivative of sin x upon sin x upon. Very simple. Similar kind of thing you can use whenever the function that will be given in the cosine form, dear student. As I told you just before I told you, the function which is given in the denominator, you get its square, cos square or cos x square. I am just going to take it because there is a small space over here, sin x upon cos x, so that you will write it easily. Okay, dear student, you see, I told you the function which is given in the denominator, you write it here as it is. Derivative of the function which is given in the numerator. In future, you can find out directly the differentiation. Okay, the function which is given in the numerator, you write it as it is. And which is given in the denominator, you write its derivative. Okay, once again you see, I got the square of the function which is given in the denominator, and the function which is in the denominator you write as it is, derivative of the function which is given in the numerator. Okay, minus derivative, wherever the function is given in the numerator, you write it as it is, derivative of the function which is given in the denominator. I think you understand this step. This is very important line. And cos x, differentiation of sin x, that is also cos x, minus sin x, and derivative of cos x just before I told you, minus sin x, and divided by cos. Actually, you try to understand. Cos x whole square means cos square x. Both the things are same. That is why there should not be confusion. Its differentiation derivative will be cos square x minus sin square x divided by cos square x. You write cos square x or cos x whole square, whatever it will be. Dear student, I discussed the 4 conditions related with the differential calculus. You must have to keep in mind these 4 conditions, 4 properties. Your differential calculus will become very easy. Because, as I told you, first you remember the definition, basic concept, then you start the solution of the simple questions, automatically you will become perfect in any topic. Dear student, let me take some questions. Already I discussed in the inverse trigonometrical function, but let me take one more question, which will be given in both the chapters, inverse trigonometrical function as well as differential calculus. But there is only the difference. In the integral calculus, in the differential calculus, you will find out that it's a differentiation, and in the inverse trigonometrical function, you will change it into simplest form. Similar kind of thing, same kind of function may be taken in the integral calculus. That is why I am taking the very important question as I discussed earlier also. Dear students, see the question. Although it is the question, it is given in the inverse trigonometrical function. That is why you will recover 2 chapters, right? In the simplest form. In the simplest form. What is the function? What is the function? Tan inverse root 1 minus cos x. Very important function upon 1 plus cos x. Dear student, you see, this is a, but condition is there, less than pi but greater than 0. X must pi. X means theta. Very important question. It is given in the inverse trigonometrical function, and I am writing it into the simplest form and differentiate with respect to x. I have extended it up to differential calculus. It is given in the inverse trigonometrical function. Write its simplest form. First of all, you will write its simplest form. And you see, the same question is given in the differential calculus. That is why I extended differentiate with respect to x. See my question. Okay, let me take the solution. Tan inverse. Similar kind of solution will be there. 1 minus cos x. 1 plus cos x. Put. See, what you will put? I discussed with you. You must have to keep in mind the chart of the trigonometrical properties. Cos to x, sin to x, all the things. That is why we will put over here 1 minus cos x will be equal to 2 cos square x by 2, because that will be half angle. If here it is given 1 minus cos to x, it will be equal to 2 cos square x only. 1 plus and 1 plus cos x is equal to 2 sin square x. These conditions you must have to keep in mind. Although we can explain this thing also, but it comes under the properties. We can find out its detailed formula. See, what will be its value? Tan inverse. Okay, here you write 2 cos square x by 2 upon 2 sin square x by 2. See, 2 will be cancelled by 2, but here it is the root of it. Then what will we write? Tan inverse root square root of it. Then what will happen? My dear student, a little modification I am just going to take, because this is the value of it and this is the value of this one. You see, a little modification I am going to do to sin square x by 2 divided by 2 cos square x by 2. Okay, that will be tan square x by 2. Little modification, and you must have to keep in mind, because while there will be the problem of the negative sign or positive sign, then calculation will be diverted in different ways. That is why you see 1 plus cos x will be equal to 2 cos square x by 2 and 1 minus cos x will be equal to 2 sin square x by 2. Okay, and it will be tan inverse. It will be tan inverse tan x by 2. And as I told you, it will be x by 2. X by 2. And let's suppose this is y. And y is equal to this one. Y will go to this one. Means you will have to differentiate this one with respect to x. How you will differentiate? Let me take differentiate with respect to x. dy upon dx. What is the value of y? dy upon dx. Y is this one. This is total y. Okay? That is why you see with respect to x, with this function you will differentiate. It will become a very lengthy. Why you will use the formula which just before I told you the quotient rule. But if you change it into simplest form, easily you can find out the solution of it. Differentiation of x is 1. That is why 1 upon 2 differentiation of x with respect to x will be equal to 1 upon 1. That is why its value will be 1 by 2. The differentiation of it is 1 by 2. Very simple. But my dear student, don't apply the wrong formula, otherwise there will be the wrong calculation. Okay? That is why you first review the property and formula, then you find out the solution. It will be better for you. Let me take some more questions related with that one. Okay? You see, this is the question in the inverse trigonometrical function. First you change it into simplest form, then you find out its differentiation. Very easy. Not many times this question asked in the CBSE examination. Okay, that is why you see carefully. Let me take some more simple questions. Okay, I have the time, so I want to take some more questions related with the inverse trigonometrical function which generally asked in the CBSE examination. Dear student, you see the thing. I am just going to take it, and generally these questions asked in the CBSE. That is why I feel, because your examination is very clear, and I feel that if I can help you in some questions, in some procedures, So that will be verified, then I must do that one. Okay, question, find the value. Find the value. Because procedure already I told you. Cos inverse 1 by 2 plus 2 sin inverse 1 by 2. I discussed already the such questions. Then you can write it in that way also, cos inverse. You see, in case of cos, because cos is here, because you can use this formula. Sin inverse, sin theta will be equal to theta. Cos inverse, cos theta will be equal to theta. But some restrictions are there, on depend upon theta. Okay, you tell me in case of cos, 1 by 2 is the value of which angle? Cos 60 degree and sin 30 degree, that is 1 by 2. But cos 60 we are required. Cos 60 how you can write? 180 by means pi by 3. Pi by 3 you can write. Okay, that will be cos pi by 3. Okay, pi by 3 means cos 60 degree, 180 by 3. 180 divided by 3, that will be 60 degree, and cos 60 degree, that will be 1 by 2. Similarly, you write this thing also to sin inverse sin 30 degree, sin 30 degree, 30 means pi by 6, pi by 6. You see, apply that case, pi by 3 plus twice pi by 6. Okay, pi by 3 plus pi by 3. You take the LCM, that will be 2 pi by 3. Very simple question, but important. Such questions actually create the confusion in the mind, how to find out the expression. But it is very simple. I feel that it is important, that is why I have taken each question in that form. This is another form to change it into the simplest form. Let me take one more question. One more question. That question also I collected from your sample papers. Let me take another question. Find the value of sin. See, very very important question I have collected to take this one. Minus sin inverse. Minus 1. Very good question. See, you write it as it is sin and pi by 3 minus, you know, sin minus theta will be equal to minus sin theta. This is the condition, and this form is given. That is why you change it into this form. That is why it will be equal to what? Plus sign will be there, because plus sin 1 by 2. Sin 1 by 2. Sin minus theta is equal to minus sin theta. And negative into negative number, that will be positive. It will become positive. Okay. Then what will happen? But here it is inverse. Don't forget it. It is inverse. Sin inverse 1 by 2. And same thing with the inverse also. Sin inverse minus theta, that is minus sin theta. Okay. Let me take another thing. Sin, just before I told you, because similar kind of question, sin inverse sin, I told you 1 upon 2 in case of sin, it is the value of which angle? 30 degree. And 30 degree you can write pi by 6. Pi by 6. 180 by 6. You will get 30 degree. Okay. Pi by 6. Okay. It will be equal to sin pi by 3 plus same thing pi by 6. There student will take its LCM 6 divided by 2 pi plus pi. It will be equal to sin 3 pi by 6, and 3 pi by 6, that is how much? Dear student, you got pi by 2, and pi by 2 means sin 90 degree, sin 90 degree. Very simple question, but students feel that it is difficult. No, it is not difficult if you know that technique. Let me take one more question of the similar type, which is very several times asked in the CSC examination. Dear student, and I do hope that in future also such type of question may be asked not only in CBSE, in other examination also. That is why you see very carefully my tan inverse 2 cos 2 sin inverse 1 by 2. Sin inverse 1 by 2. See carefully. Similar kind of thing I am taking. That is why I collected the similar kind of questions which will be helpful for you. Tan inverse 2 cos and 2 sin. See sin inverse. But 1 by 2 just before I told you sin 5 by how much? 30 degree means 6. Okay. It will be 2 cos and it will be 2 into its value will be 5 by 6. As I have given already, tan inverse 2 cos, it will be 5 by 3. 5 by 3. Cancel 6 by 2, 3, 5 by 3. Okay, tan inverse 2 cos 5 by 3. Cos 5 by 3 means 60 degree. And cos 60 degree that will be, dear student, you know 1 by 2 and tan inverse 1. Already I told you its value. Tan inverse 1. That is how much? 45 degree 5 by 4. That will be its value. I do hope that today I have discussed the questions related with the inverse trigonometrical function, as well as I started the differentiability of different types of function and 4 properties. My dear student, you must have to check it and generate some questions and find out its solution related with these simple properties related with your differential calculus as well as the inverse trigonometrical function. In future also we will discuss some questions in other videos. My dear student, if you like my videos, then I shall be motivated. Okay, and subscribe my channel as well. Okay, thank you to all of you.